The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to today's webinar, Java, Database, and More using Oracle Solaris as your optimal platform for Oracle software. Our speaker today is Larry Wake. Larry Wake is responsible for strategy and messaging within the Oracle Solaris Product Marketing Group at Oracle Corporation. He has worked with the Unix operating system in various technical and product management capacities since 1979. Prior to joining Oracle in February 2010, he worked for Sun Microsystems for 20 years. Larry is one of the most requested speakers on Oracle Solaris and Oracle's OS and software strategy as a result of his extensive experience in these areas. As a staff member at California State University, Larry was technical representative for the system at the Inter-University Consortium for Educational Computing, ICEC, one of the earliest development grounds for technologies including distributed computing and advanced Windows systems. Larry is the co-author of Practical XView Programming, a topic he freely admits may no longer be very practical, published by John Wiley & Sons. Before we begin, I would like to remind the audience to please feel free to submit questions throughout the event via the question chat box on your webinar toolbar. Our speaker will reserve time at the end of today's presentation to take your questions. I would now like to turn the call over to today's speaker. Please go ahead, Larry.
Okay, great, and thank you very much, and thank you all for attending. As was mentioned, I've kind of been in this rodeo for a little while. I joined Sun in 1989 and did not start out specializing in operating systems. That became something that happened a little more relatively recently, but had a chance to see a lot of things happening here. And one of the big shifts that's been happening, and I think it's been accelerated by Sun becoming part of Oracle, is the way that the role of the operating system has changed. When we're talking about things like platform as a service and infrastructure as a service, the operating system has to be more than just what in 1989 people thought an operating system would do. And hopefully we'll be able to demonstrate today that there's just a lot more going on with Solaris than there has ever been before, and really more, we think, than any other operating system out there, and that's sort of the point of the whole thing. And Oracle's continued and accelerated investment in Solaris has really given us the opportunity to do more than we were ever able to do before. So let's get started and talk about what's going on. This is just a picture that we took of some of the very many people who are working on Solaris these days. If you've ever had a chance to come to the Santa Clara campus, what was formerly Sun's headquarters campus and is now Oracle Central for what we're doing with our hardware systems and software technologies, including Solaris and Java. It's a big campus, and it's jammed now. We are hiring like crazy. There are things that we're doing that we're bringing in more and more expertise into the company. I thought what I'd start with is just kind of a status check into how this is all panning out with what we've been doing. So when we joined Oracle in 2010, a lot of people wondered, well, what are you going to do with Spark? What are you going to do with Solaris? Obviously, Sun had been having some, let's call them challenges in keeping up, frankly, with what was going on in the industry. And what Oracle was able to bring to the table to us, as well as just, as I said, the increased and accelerated investment, is it gave us more of a sense of focus. Oracle was very clear on what they wanted the hardware system to do, what they wanted the operating system to do, what they wanted Java to do, and what it was to make sure that the folks who were using Oracle software and other third-party software out there were getting the best platform available. And it really took a lot of the clutter out of our vision. We set some roadmaps literally on day one when we announced that the acquisition was closed, and we've beat those roadmaps, which is pretty unusual. If you've been in the industry for a while, you know that that's kind of unusual. We got Oracle Solaris 11 out the door in 2011. We got Oracle Solaris 11.1 out the door a year later, and we're, of course, working now on Oracle Solaris 11.2. We have the beta release for that out right now, and that's a lot of what we're going to talk about today. Our friends over on the hardware side have also done some pretty amazing things as well with the Spark roadmap. Again, Spark was kind of lagging behind the rest of the industry. We have now just zipped forward. In the time that since the acquisition, we released several generations of the Spark processor, and the gains in that have been incredible. The M5 and M6 are just brilliant processors, and they're really the best way I can put it is it's really living up to the promise of what we said we were going to do when we did the project that was called Niagara, when we did Cool Threads Technology. And we're very gratified to see that our other friends out there developing other processors have taken this to heart and are doing pretty much the same thing we started doing a very long time ago. The big thing, if people ask me, well, what's the big difference between what you were doing with Solaris at Sun and what you're doing with Solaris at Oracle? It's the fact that we are now intimately involved with everything that's going on in the development of Oracle software platforms. Where it used to be that, Sun and Oracle were very good partners for a very, very long time. But what that usually involved was a couple of times a year, we'd all get wound up, we'd get the lawyers together, and we'd figure out what we could talk about, and we'd have a big meeting for a couple of days, and we'd figure out what we could share with each other. This is now called Tuesday, right? It's Monday and Wednesday and Thursday and Friday as well, possibly Saturday and Sunday, where we're just together with the database teams, the Java teams, the people who are developing all the other software up and down the stack, the Spark people. Everybody is working together, and the idea is that we're building, testing, co-engineering this. You may have heard some taglines that we develop around this, so I won't bore you to death with that. But the idea now is that Oracle Solaris is in the heart of everything that's going on at Oracle. We run Oracle on Oracle Solaris as well. Every order that comes in, all the things that we deliver are processed on a single image based on Oracle Solaris and Spark. So some cool stuff going on there, and that's what we're going to talk about today. What this gives to us is the ability to deliver an operating system that is, people laughed when we first started talking about this because it seemed like cloud was just the buzzword for du jour. When we released Oracle Solaris 11, we said this was an operating system that was designed for cloud, engineered for cloud, and people went, well, what the heck does that mean? Because we've been using the cloud with other operating systems besides Solaris for a very long time. We said, well, we're bringing something to the table that we don't think anybody else can do nearly as well as us, is that the things that made Solaris the go-to operating system for enterprise computing for a very long time, that's all still there. And what's happened now is that we're integrating that in with the things that we think are absolutely critical to cloud computing technology. And they're things that Solaris did not necessarily have before or were in nascent stages, but over the last several years, virtualization technology, which came in Solaris 10, what was called Solaris Containers, now Solaris Zones, the ability to create multiple virtualization instances at really pretty close to engineering zero overhead, and we'll talk a little bit more about that. One of the areas that I never was able to say in the Sun days was a strength of Solaris was what we were doing for provisioning, software installation, software packaging, software management. We've leapfrogged now, and we are doing some things, again, that I don't think anybody else can do in terms of platform provisioning delivery. Security has always been a strength in Sun. We're going to talk about some of the things that we're doing in Oracle Solaris now that allow us to lock down a complete virtualized environment, which again we think is critical to cloud computing, and CNN seems to be able to bring up daily reports of people who are learning this the hard way, so we don't want that to happen to our customers. Application-driven SDN, this is something, software-defined networking is something that we've been working on in Solaris 11. This morning we're delivering even more news on that if you've been watching the PR wires, and if so, why? Don't you have anything better to do? But we'll talk a little bit more about that. Scalable data management, the things we've done with ZFS. ZFS moved from people scratching their heads trying to figure out why anybody would need a new file system to become the file system that everybody wants to imitate, emulate, or integrate into their operating system. And another area that we've found to be very important, connected to but a little bit separate from the idea of security, is we want to be able to secure the system, but more importantly we want to be able to demonstrate that the system is secure to our colleagues out there, such as auditors and external organizations. And we also want to be able to determine if there are places where we are not doing the right things in terms of security compliance so that we can actually mitigate it as well. So compliance has become a very big part of what we're doing. And again, if you happen to have been tracking what we were doing in Solaris 11, Solaris 11.1, and what we're talking about in Solaris 11.2, we've got some pretty exciting stuff that's going on there. One of the things that you'll also notice, by the way, about all of this is that we're doing it with an eye towards making sure we're fully standards compliant, we're fully interoperable, and a key thing which we'll talk about here is we want to make sure that this is something that you can integrate into your business very easily, that if you have expertise in other Unix operating systems, if you have expertise in Linux, integrating Solaris into your organization is easier than ever. And that's kind of a big deal to us because as we're going out and delivering the systems that we are, over half of the new deployments that we've been doing over the last couple of years, we've been measuring, over half of them are either greenfield applications, people standing up things from scratch, or they're transitions from competitive environments. So these are people who have not used Solaris before. And we want to make sure we're bringing in that technology so that people can pull up the skill sets and get going right away. The way I look at it, when we're doing system administration, we want to make sure that people are able to look at Solaris, say, I know this, I get how to do this, and I can start learning all the new, unique things that we're doing in Solaris that we think make us stand apart from the rest of the world as well. So we want to extend. We don't want to be kind of this weird, quirky, orthogonal thing out there as well. So let's talk a bit more about what all this means. So we announced at the end of April Oracle Solaris 11.2. We're in beta right now. We will be delivering what we'll call later this year, or Oracle Solaris 11.2. Not an incredibly long time from now, but can't release the exact date at this point. But what are the big pieces of news? Well, probably the thing that's caught most people's eye is Oracle Solaris 11.2 is a fully integrated enterprise OpenStack distribution. That means that we play well with any place that you'd be plugging in OpenStack. You'd be interoperating with OpenStack distributions. Anything that you want to do in the areas of provisioning and management using OpenStack, Oracle Solaris is ready to go out of the box. And we'll talk a little bit more about that before we're done. Mentioned software-defined networking before, where we, again, believe that we can provide unique value as part of Oracle, is that we can talk about this from the application layer on down. We can actually deliver Oracle applications that understand how to do software-defined networking, can connect with the interfaces with Solaris. Solaris, in turn, can connect with the interfaces out in your networking environment so that you don't have to touch a piece of network hardware once you've got everything set up. You can create your flows, you can create your service level agreements, you can make sure quality of service and monitoring is all ready to go, and we'll talk a little bit more about that as we go. I mentioned zones earlier, our built-in zero overhead virtualization technology. If you're familiar at all with zones, you know that the way that it works is that rather than having to have a separate hypervisor layer below your operating system so that you can deploy multiple operating systems with all the overhead associated with that, instead we say, well, what you're really trying to do, and we're again, excited to see that the industry is kind of picking up on the same ideas, is you create containers within a single operating system instance. And those containers are managed as though they're separate OSs, but they don't have the overhead of the separate OSs. The way we do that is that everybody shares the same kernel technology, which means, and this is the downside to this, is that if you're deploying 100 instances on one instance of Solaris, called Solaris 11.1, all of those instances are Solaris 11.1 instances, which may work out very well. It may not be flexible enough for what you want to do. What we're introducing in Oracle Solaris 11.2 is the ability to now have separate kernel instances within the containers, still maintaining this near zero overhead capability that we have now, but giving you the capability of doing something like having an environment where you're running Oracle Solaris 11.2 underneath, and you have different kernel revisions of Oracle Solaris running on top of that. Now, if you're running on a Spark system, this does not mean that you can suddenly run x86 versions of operating systems. Just be aware of that. We're not doing anything in terms of binary translation. If you're running in an x86 environment, there's a little bit more flexibility and potential. But right at this moment, we're still talking about running Oracle Solaris instances on top of Oracle Solaris. We'll go into this a little bit more. Unified archives, this is another thing that I think has been lacking to be perfectly honest, in Solaris in a very long time, is the ability to take snapshots of your operating system environment, bundle that up, create a bootable instance that you can then redeploy. There are other operating systems out there that have been able to do that much better than us. We again believe that we're leapfrogging ahead, though, and with unified archives, a new technology we're introducing in 11.2, we're now going to have the capability to create universally deployable instances that can then be used to do take a physical image, deploy it on another physical system, deploy it on another virtual system, move from one virtualization technology to another, and just be able to create very flexible, very standardized deployment instances that you can move out anywhere that you need to. So we think this just adds a much needed and very robust layer to what we're able to deploy with the operating system. As I mentioned, security and compliance are very important to us. I'm not going to go into too great detail on that today. There are a couple of things that I do want to highlight, though. In compliance, we have a new command in the operating system, and it's a pretty straightforward command. The name of the command is compliance. And what the compliance command allows you to do is take templates that have been defined either by yourself, by other organizations within your company, or other standards-based instances out there, not just for Solaris, but for anything out there. So if you're doing payment card type things, you want to comply with the PCI standard, you'll be able to run the compliance command to see whether your environment right now is compliant with the recommended or mandatory standards that are required by the industry, by your auditors, whoever's out there. So we think that's pretty exciting. In terms of security, we're doing something that I think, again, kind of got a little buried in the other big news that we have in here. In earlier releases of Solaris, we introduced something called immutable zones. And the idea behind an immutable zone is that everything except that your data is read-only. And there is no way that if somebody hacks into a particular zone, that they can change anything in the operating system. They can't put exciting new commands in there. They can't substitute other commands because it's all absolutely unreadable unless you're going in through the trusted path that is necessary for configuring, which is not accessible. In Oracle Solaris 11.2, we're taking that into the global environment as well, so that you can create physical environments that are read-only, in which you can then run virtualized environments on top of as well. So we're providing what we think is some pretty solid security, which again we believe is very necessary in today's environments, especially as you're pushing more and more things out into either private or hybrid or public clouds. And then the other thing, which sometimes if you see a presentation like this, you'll see it sort of turned around upside down backwards, is that people will talk about, well, and this is sort of classic 20th century speak, you know, the operating system provides much more performance capabilities for what you're deploying out there. Yes, we are doing that in Oracle Solaris, but we don't believe that's actually the big news in this release. There's a lot of things that we're doing for managing Java and database specifically and making sure that the performance is there. But really what we believe makes Oracle Solaris the best deployment environment out there is beyond the performance. Performance is important, but we believe all the things you need to do for deployment management and security, and to make that as easy as possible, as fast as possible, and as flexible as possible is really what's key to making Solaris the most interesting platform out there, if operating systems can indeed be called interesting. I think they do. So let's talk a little bit about OpenStack. First of all, for those of you who are not as familiar with this, this is one of the very rapidly emerging technologies. We just finished participating in our third public appearance at the OpenStack conferences, which occur about every 6 months. And the growth over those 3 sessions has been absolutely phenomenal. It's gone from being sort of a club of people going, hey, let's put together a show, to something that every player in the industry is now participating in heavily. Oracle was there, IBM was there, HP was there, Red Hat, of course, was there. Didn't see Microsoft there as much, but there's some interesting things that are being done in that area. VMware, just, you know, every major company that is doing interesting things with compute and the cloud is now part of the OpenStack consortium, and just a lot of cool things going on out there. What it is it's a framework for managing and deploying cloud-based compute instances. And there are different kinds of resources that are out there. You're managing compute, you're managing network, you're managing storage, you're taking a look at all the things that are going on. There's the core development technologies that are happening in OpenStack that allow you to deploy all these virtualized environments. And then there's a growing sort of cloud of, if you will, of new technologies that are surrounding that as well. But the idea is that you can now have web-based portals and API-based administration of the cloud services out there. And the key part, of course, is that it's interoperable. All the different types of virtualization technologies out there, the deployment technologies that are out there, they can all communicate with each other and be used to manage, deploy, and reconfigure instances. So it's pretty exciting stuff. The idea behind it is, again, just making sure that there's no one player in the industry that is just locking in everything that's happening out there. And we're pretty excited that Solaris is just right there neck deep in all the things that we can do as we go out there. So what does that mean? Well, as I said, there are these different technologies. There's compute virtualization. The name for that in OpenStack is Nova. Cloud networking, the name is Neutron. Cloud storage, there are components for block and other types of storage, so that's Cinder and Swift. And not the same Swift that Apple just announced, of course. And then image deployment technology is called Glance. Now, what we've done is we've integrated this all into the operating system. This is not plugins. This is not bolt-ons. And where we believe that we're providing significant value is that for each of these types of components, we're tying into things that are unique to Solaris and making sure that we're delivering these in a way that we would argue is better than anybody else can do out there. So when we talk about doing compute virtualization, we talk about using zones and kernel zones, as I discussed earlier. When we're doing cloud networking, this is what we're doing with application-driven SDN and the technology that we're introducing in Solaris 11.2 called the Elastic Virtual Switch, which allows us, again, to very dynamically define virtualized network resources. And if you're familiar at all with what we've been doing in Oracle Solaris 11, you know that the types of network virtualization that we can do within the OS is enormously flexible, enormously powerful, and enormously comprehensive. The virtual network technology is very strong, so we tie that right into Neutron. So when you're doing Neutron on Oracle Solaris 11, you're using these unique features. When you're doing the storage type technologies, you're tapping right into what we think, again, is the file system to beat out there in the world right now, which is ZFS. And we're not only doing this in Solaris, by the way, we're doing this in the other technologies within Oracle as well, so that when we have something like the ZFS storage appliance, it's going to have OpenStack management capabilities built into it as well. And then when we're doing image deployment, we're doing this technology that we'll talk about in a little more detail called Unified Archives. So again, this is all built directly into the operating system. It's fully supported as part of what's going on with Solaris, and we believe that this is going to be something that is going to provide immense value to the Solaris users out there. So let's go back to kernel zones, talk a little bit more about that and what it gives us the capability to do. I think I've given you most of the news on this, is that not only does it allow you to create these sorry, just lost the thread a little bit. Not only does it allow you to create these virtualized zones on top of them, but you can now create different versions as you go at the same time. And what this allows you to do very easily is take physical instances that you were running on earlier versions of Solaris and run them virtually on tops of current versions of Solaris without changing the environments at all. So, you know, when we say seamless, we mean seamless. It's you take it off a physical system, move it into the virtualized environment. You don't have to worry about what was going on in terms of translating that. Similarly, you can take what was a virtualized environment, move it directly into a physical system as well. And as I mentioned, one of the key security features of this is that you can lock down the entire environment so that it is absolutely read-only and is not alterable by anybody out on the system as well. So let's talk about Unified Archives. This ties in very nicely to this at all, and what this ties into this very nicely as well. And what this gives us the capability of doing is very agile provisioning And one of the things that I want to highlight as we go through this particular thing is that it ties in with all the other features that we were talking about before. So if you're in the development environment, you create a system that you want to go out and deploy, you test it, you find out that's great, integrate in the database, integrate in the applications, you're ready to go. You now want to create that archive and you want to hand it off to your operations people. Well, one of the things that you want to do as you set that up is you want to be able to test it for compliance. So you test it, you make sure that it has everything that you need, and you deploy it as a unified archive. Your operations people now go off and deploy it in a production environment, and you know because you've tested it in advance and it's created as a unified archive, it's locked in, ready to go, secure in production. You can then have it in a lockdown configuration so that nobody can break in and do anything that you want to do. And at any time that you're running it, you can go back and verify that that environment is the environment that you have, that your developers have. So getting from the developer stage to the operations stage, it's configured, it's tested, and it's reproducible and verifiable all through the same steps. And what this allows you to do is not only very securely deploy everything that you're doing here, very quickly create multiple instances out there. By the way, if you're familiar with the way that CFS works, if you're creating these multiple instances in zones on top of Solaris, you're also not duplicating all that data. It's automatically deduplicated at a very efficient, very high performance, and just enormously compact level. We've seen people get about 10-fold resource reclamation because of being able to do this on top of CFS. So this is a typical environment. This is not, if you're familiar with Solaris from the days of Solaris 8 or something like that, this is not the sort of experience that you had before. You find out that there's a new security fix available. Your maintenance window is 6 o'clock. You set it up, you get going, you start the update, everything happens in the background. You're ready to go in 2 minutes. This is not a normal experience for people who haven't been familiar with at least Solaris 10. If your experience with Solaris goes back to Solaris 8 or Solaris 9, this is really more than interesting. It's kind of a shock. The first time that I was actually able to do something like this on my laptop, I was blown away at how easy it is to not only determine that there is a new fix available, but to be able to deploy it and get it up and running very quickly. One of the nice things for people in the operations world who understand, though, that sometimes things go wrong. Sometimes the security fix that you got isn't the security fix you wanted to deploy. Sometimes it creates a disruption somewhere else out there. You need to roll it back. Because of the way that CFS works and its copy on write capabilities, and because of what we've integrated in with Solaris 10 and now Solaris 11 in the ability to be able to create separate boot environments, we can roll it back. So rollback is, again, about a 2-minute process. So if I want to go from state X to state Y, discover that state Y was not the state that I wanted, I can actually get back to state X, and the total time that I had that particular trip was about 4 minutes. Now what we want to look at is what happens if you tie all this together with OpenStack. One of the things that we're seeing as organizations are looking at OpenStack, one of the biggest challenges that they have is that not all of this is baked in right now. And again, this is what we think is one of the key values of Oracle Solaris and the way that we've tied in OpenStack, is that we're baking it in. We're integrating it in. And a lot of environments are taking a look at OpenStack, evaluating it, trying to hire the people, the engineers that they need who have the expertise in doing OpenStack integration, and discovering they're gone. You know, again, this is exploding, and all the people who have this expertise are tending to get hired away by other companies. So if you haven't got your OpenStack people, you're already starting to think, well, this might take a couple of years to get the training and get the expertise going. What we're creating with Solaris is an environment where we can actually get from bare metal environments to cloud in 10 minutes without requiring that you change the way that you do your operational configurations. You know, especially if you're already a Solaris shop, this stuff ties in very quickly. But again, because of the things that we're doing in terms of integrating in management capabilities such as Puppet and Chef and all the things that people are used to using in other environments as well, this is something where you get to your level of familiarity very quickly, and then you start being able to add in the new capabilities. So what we're seeing is people who can get from an absolute bare metal compute environment to ready to deploy in the cloud with the Solaris distributions and the OpenStack unified archives that we're able to create in 10 minutes. And we think that's pretty exciting. The one other thing that I'll just mention very quickly as part of this, and I know, oops, did I lose an animation here, is that where we see some of the value in, and I talked about the fact that performance is sometimes what we lead with. The other thing a lot of people try to lead with in a lot of talks like this is how much money you're going to save. So I thought I'd at least make one mention to this. When we look at the way that we do virtualization and what we include with Solaris and the management capabilities and the interoperability that's in there and the efficiencies that we get with Spark, we have a very large communications organization that we're dealing with. We did the analysis, and they figured out they are saving at least, this is not an up to, this is an at least $500 per virtualized instance that they put out there. As it turns out, they were deploying in their first run 4,000 virtualized instances. So they're looking at this and saying, well, gee, at $500 per VM, I just saved a couple of $1 million by doing this deployment on Solaris at least. So that's just capital expenditures too. This is not operational expenses, and we've seen people who are actually demonstrating that they can get about 16-fold, 16 times greater efficiency administering Solaris systems compared to other systems out there. So this will be my one little bit of the money pitch here, but this is not just sort of an abstract, boy, there's some cool technology in Solaris. We're seeing some companies that are saving some tremendous amounts of money as they go out there. We'll go back to the technology a little bit. Application-driven SDN. So I mentioned there is a new bit of news this morning. We just announced that we are joining the Open Daylight Foundation as a silver member. So what this means to you is when you're talking about software-defined networking, one of the things that you want to be sure you're able to do is interoperate with the network technologies out there. So Open Daylight is a pretty exciting consortium because, again, it has all the major hardware players in the industry out there. So the idea is that if your software-defined networking, as it is in Solaris, is based on standards, then it's very easy to create these flows, not only across Solaris systems, but other systems that you're administering out there. So this has some very nice direct effects, and we'll talk a little bit about this as we go forward, as we get a little more specific about database in Java. With Oracle Database 12c, obviously the big news there, or at least one piece of big news, is pluggable databases. Pluggable databases are configured with software-defined networking, and we'll talk a little bit more about that. When you're talking about Oracle RAC, you want to make sure that you're maintaining your heartbeat levels across the network. This, again, is a built-in feature in here so that we're protecting your heartbeat as you go through. And again, in Java 8, SLAs are built in as well. So all these things move up and down the stack, configure with Solaris, then move out to the hardware layer so that we're able to actually create guaranteed network flows as we go across the network. So the title of this presentation talked a bit about Oracle Database in Java, and as I said, I didn't want to necessarily be just specific about technical things that we're doing within those environments, but I also want to spend, at least a good half of the presentation talking about that as well. So, as I mentioned at the very beginning, one of the key values that we can provide with Oracle Solaris and the other technologies that we have within the company is integrating them together all the way up and down the stack. And by the way, there is something missing from this presentation, and at the end maybe I'll ask a question of you guys and tell you, what did I leave out of this presentation? We'll talk about that before we're done. But the idea here is that we are building best-of-breed hardware technologies, and that's based on both Spark and x86 systems, of course. It is co-engineering as we take the applications and the hardware and put them together. And then one of the things that we've also been driving at, and Oracle actually started working on this before Sun became part of the company, is another idea that is being very widely emulated in the industry right now, which is delivering complete engineered systems. So we provide this at different levels because we know some companies want to do this at the component level and build their own systems. We know that some people want to take best practices and recommendations, such as our solutions that we offer, and make sure that those are co-engineered and tested. And then for the greatest co-engineering value, if you will, it's what we're able to do by integrating in the systems together. The work that we're doing with Solaris applies to all of this. And one thing that I want to stress is that it does not just apply to Java. It does not just apply to Oracle Database, but it applies to third-party components as well. But where we put our focus and where we put our day-to-day expertise, as I say, we call it Tuesday, is being able to sit there with the engineers in the company who are building database, who are building Java, who are building things like WebLogic, who are building the top-level applications, and make sure that we're doing the right things at the Solaris level and at the hardware level to get those systems the highest performance they can. There are very few companies in the world that have this opportunity, and I will argue we do it better and more comprehensively than anybody else can. So this is one of those interesting slides where we decided to put together what have we been doing in Solaris for really the last 20 years, and what have we been doing lately to make sure that Oracle Database performs better. And there's an incredible amount of work. Back when it was the meet a couple of times a year days, we were still engineering systems with hundreds of cores, thousands of hardware threads, and making sure that the folks at Oracle Database knew what we were doing and that we knew what the kind of things that they were doing to integrate all these components in. As we're building systems with just crazy amounts of memory, you know, we're delivering systems on a regular basis now with 32 terabytes of physical memory, and I remember when 1 terabyte databases were considered to be a pretty impressive thing. So you look up and down the line, what are we doing with CPU, memory, file system, and I/O? We highlight in red some of the things that we've done in Oracle Solaris 11.2. However, what I like to do is just kind of try to net it out. You know, we are optimizing both the database and Solaris to make sure that we're taking the best advantage of threaded hardware. We're making sure that we're building systems that are ready for the concepts of big data, big memory, and also big virtualization. And again, when we're talking about saving $500 per virtualized instance, imagine how many virtualized instances you can put on a 32 terabyte system. It gets pretty exciting, and there's some companies that are doing some pretty crazy stuff in that world right now. When we talk about the new things we're doing in file systems, it's creating interfaces so that as Oracle Database is creating these new data technologies, it just plugs in seamlessly to what we're doing at the operating system level. Making sure that we're creating advanced networking technologies, keeping track of all the latest things that are happening in InfiniBand, making sure that we're doing all the things that we need to do to present software-defined networking technologies up to the higher levels. Other areas, observability, reliability, and availability. The performance, as we've mentioned before, you can see there's been a lot of stuff we've been doing over the years, but again, if you net it out, it's being able to observe what's going on in the network, be able to tune it for highest performance, be able to configure not just the software for networking, but the hardware on the fly. So being able to do hot plug and remove of InfiniBand components is important as you're doing your reconfigurations, and we'll talk a little bit more about that. Making sure that we've got the best network virtualization and that we're taking advantage of the onboard hardware support for that as well. Making sure that we now have this additional level of flexibility for zones, and then making sure that we're hardening the systems for deployment in cloud environments. So there's a lot of work that we're doing. As we describe it here, it's just the tip of the iceberg. The work that we're doing in conjunction with the database team is ongoing, and it's pretty exciting. And I'll talk a little bit more about kind of how that translates further up and down the stack a little bit later. Other fun stuff, we talked to the Oracle RAC team once, and they said, yeah, that's very interesting, you guys, in the operating system, but we've tuned the heck out of Oracle RAC. You know, we just don't really see where you can go into the operating system and actually make what we're doing any faster. And we said, well, let's take a look at locks and take a look at the latency involved with that. What if we were able to take an additional step out of managing locks and do that within the kernel of the operating system so that that offloads it and that there's a little bit less of a trip going across the network and going through the kernel every time that you're checking a lock, because that happens a lot. And what we're able to deliver is 30 to 40% lower latency in terms of managing locks, which translated to up to 20% higher throughput. And they said, okay, that's pretty big. We actually like that. So again, this idea of being able to have the teams work together and find new things that they can do for optimization really pays off. And we don't see any reason why that should stop as we continue on. Scalability is important to us because we are building these very large systems. You know, we talk about a system that actually has 384 hardware threads on the system. We look at the way that virtualization is normally done by other virtualization technologies out there. And my understanding is that some of these virtualization technologies do not actually allow you to publish benchmarks if you mention them by name. So we'll just say there's another very popular virtualization technology that if you look at their scalability, they scale to kind of 48 threads, and they consider that good. If you look on this slide here, you'll see there's a little green box down in the lower left-hand corner of the graph, and that shows their scalability, and it's pretty close to linear. The black line on this shows ideal scalability for 384 nodes, where you get basically the equivalent of 384 cores on a 384 core system. The red line shows we didn't quite get full linear scalability. You know, if we're running 384 cores, we get about, say, 370. We think that's pretty good. And this is the kind of thing that we can maintain. We have always been able to demonstrate scalability with Solaris. And again, we don't see any reason for that to stop. And part of the reason for that is, again, we are working intimately with our friends over on the hardware design side as we do this. And again, there are very few companies that are actually sitting there designing the processor and designing the operating system at the same time. Think about which companies can do that. There are really only a couple out there that are doing both. I mentioned processor performance. I'm not going to go into great detail on this because we already hit this, but just to sort of look at it on a graph, this, our best performing system before the Oracle acquisition was our M9000 system. And shortly after the acquisition, we were able to demonstrate that we were able to get it to bump up a little bit. And that's when we started really lighting the fuse with what we were doing with the T-Series systems. And you can see we've gone just amazing performance jumps on here. If you compare that to what other processors have been doing during the same time frame, it's nothing like this at all. And as you might imagine, we've got other processor technologies coming out. We don't have the M6 mentioned on this particular slide, although that's been out for a while. So you would think that probably the next number coming on the system would be 7. We can't really talk about what we're doing quite yet, but I think when we actually are able to talk about it, and that might be as soon as Open World, we'll see. Once again, this is not a disclosure of any sort of product announcements or release times. Just stay tuned in Open World. Hopefully we'll be able to discuss a little bit more about where we're going with the hardware. We continue to be very excited about what's going on here. One of the things that makes that very exciting, by the way, is not only what we can do in terms of raw cycles, but what we can offload into the hardware. So we'll talk about that a little bit later. I'm going to skip over this slide because we kind of already talked about this before, is how we're able to drive expenses down by including things in the system that nobody else has, being able to put more virtualized instances on the system. We think this is pretty important for deploying Java, for deploying database, for really deploying anything out there, because most people, when they're doing deployments right now, virtualization has become their go-to environment. So let's continue to drive that down. When we're able to actually do database benchmarking in a virtualized instance, we're able to do it at a lower cost per TPM than one of the more popular delivery systems out there. Performance is key. Availability is key as well. A system that is not running has a performance level of 0, so we want to keep the systems up as often as we can. We want to do this in depth. This is very much like security. We talk about defense in depth. You want to do availability in depth as well. So again, Solaris and Spark hardware and x86 hardware are engineered together so that if there are hardware faults, we're able to recover as quickly as possible. Our favorite recovery mode is when we don't bring down the application, and we can do that in a lot of instances. Now that we're in I used to talk about this as though it were a unique thing, that we're in an environment where you have multiple cores on a system, but everybody has multiple cores now. So if a core fails, if your operating system can actually keep going in the face of something that used to be a complete catastrophe, you're doing pretty well indeed. And we've been able to do that since Solaris 8. So node fails out, we just continue to run. If a service fails on top of a node, even if you're not in a clustered environment, we can restart that service seamlessly. One of the things that I think is very exciting and sort of an unheralded function of Solaris is that not only can we restart that service, we can also coordinate the management of other services that are running out there. So if service A fails and service B is dependent on it, we can determine whether we need to restart service B or even just nudge service B and say, by the way, did you notice that service A had a problem? You probably want to reread your configurations. So that's very flexible, and it's a key part of what we integrate into Solaris. And again, with something like Unified Archives, you can create environments that are just turnkey and roll out and understand all those things as a coordinated whole. Heartbeat traffic protection, I mentioned this earlier, the fact that we can actually isolate flows within the network environment so that if you have something like a rack heartbeat, we can protect that and make sure that it stays up so that you don't have any false failures while you're running on here. Multi-node HA with Solaris clusters built in as well. Not only that, but we also, of course, have multi-site disaster recovery so that you can actually do global recovery in the face of site-wide outages. One of the things you might have also noticed on the previous slide was database startup. You don't want to restart your database, but when you have to restart the database, you want to do it as quickly as possible. In a 32 terabyte database environment, it used to take us, 47 minutes to restart. So we started taking a look at that and saying, what can we do to shorten database time, because 47 minutes is a heck of a long time. It's about as long as I've been talking right now, so you can imagine waiting for your database while listening to somebody like me talk. We got that down. We did some analysis within the operating system and say there are a lot of parallel services that we can start. There are a lot of things that we can do to reconfigure what's going on with the database in parallel, and we just did that on our own, and we got it down so that we could now restart the system in around 11 minutes. So getting down to 47 minutes to 11 minutes, that's pretty good. This is the co-engineering aspect, though. When we presented this to the Oracle database team, they said, that's great, let's take a look about what we can do if we do this as an integrated whole. And they made some changes within the database based on what they learned about Solaris and what we showed them and what we demonstrated. And we now got that down from about 11 minutes to about 2 minutes. So down from 47 minutes to 2 minutes for a restart on a 32 terabyte system. It's pretty good. So again, this is the sort of thing you can do if you actually have the teams talking to each other. Another thing that we looked at is saying, well, what if we don't want to restart the database? What if we're doing something like we're resizing the database? Can we do that without taking down the database? So we introduced a technology in Solaris called Optimized Shared Memory, which works with what's inside of Oracle DB. We actually got it now so that we can actually resize the SGA without bringing down the system at all. So 0, even better than 2 minutes. Okay, so how does this tie in with pluggable database? Well, again, the idea behind application-driven networking is you've got a couple of databases which we have cleverly labeled B and C because they're not the primary service on the system. You know, we've got B and C here, but now we want to fire up A. A wants a bigger network pipe. So we go ahead and we grant that to it. Drop it on in there, it automatically gets configured, and we automatically resize the amount of networking that's available to the other pluggable databases based on the configuration information that's going on at the database level. So this is something where we're not configuring this with network services, we're actually configuring this as part of how we're configuring the database itself. So again, up and down the stack from the database all the way down through the hardware is automatically configurable. Okay, another key piece of integration that we always thought would be kind of cool is there are 2 ways that you can use the observability technology within Solaris, which is called dtrace, if you're familiar with that at all. It's basically like having a glass panel on the side of your computer so you can see what's going on all the time. So there are 2 things we could usually think of traditionally. One is looking at the database from the operating system level and saying, how's the database performing and how do we tune that? That's kind of interesting. It's especially interesting to the Oracle database development team, and they do use dtrace for things like that. But the other thing that becomes more interesting is if you actually make the application itself, the database looking like an application to the OS, and make the application aware of dtrace so that it can look at what's going on in the operating system, which actually gets a lot more interesting. And what we've done is built into $V views in Oracle Database 12c the ability to actually determine when transactions are taking longer than they really ought to, is that you've exceeded some threshold and things just aren't coming back off the hardware as fast as you want to, which is usually a sign that you've got a problem with either your connection to the disk or possibly to the disk itself. But you don't want to get the hardware structure team involved. You don't want to get the storage team involved. You really want to just figure it out yourself. Well, Oracle Database now uses dtrace to actually be able to reach in and determine which transactions are having that problem and actually correlate it and say, this ties into a very specific hardware device, so that you can actually go back now and say, look, there's this one particular piece of spinning rust that is causing problems, and all my transactions on that particular device is causing the problem. Let's fix that. And you can go in and get that analyzed and solved much quicker than you were ever able to do before. I was going to mention this, I forgot. Yeah, if you want to see a demo of that, one thing I'll just sort of pre-announce, we've got a great YouTube channel out there, the Oracle Solaris YouTube channel. It is youtube.com/Oracle Solaris. Oddly enough, you can actually jump using the bit.ly link here to a dtrace database demo. It's about an 11-minute video that shows how this is actually used, and that's kind of cool. So, but if you don't remember the bit.ly link, just remember to go take a look at the Oracle Solaris YouTube channel. You'll find it there. So, Java, again, why are we the best platform for Java? Well, one of the things that we've done is we've just worked the hell out of performance on Java. We did this in Java 7. You can see the increase in performance that we were able to get between Java 7, between early iterations of Java 7 to later iterations. But the work that we've done in Java 8 using the combination of the T5 processor, Solaris 11 and Java 8, has been absolutely enormous. One of the things people are talking about is how do you get the best performance out of Lambda expressions. They're very functionally useful for developers, but is there too much abstraction happening there? We've done a lot of work to make sure that we get the best performance possible out there. Support for the really large memory pages that our new hardware can support as well. Making sure we've got Java locking well integrated. As I mentioned, of course, being able to do the network flows for SLA integration. So just a lot of tremendous things going on. We'll talk about this last bullet, Java GC support, in just a little bit. Getting close to wrapping up here, but do want to make sure that we cover everything that we've got. Again, beyond performance, there's also visualization, being able to see what's going on in the system. So there's something called Java Mission Control. When deployed on Solaris, it has a dtrace plugin, so it's able to actually get in there and get the most comprehensive views into what's going on your system as well. This is a unique Solaris advantage. So it gives you the ability to see very intimately what's going on the system. dtrace has been highly optimized so that it actually understands what a JVM is and what are all the different things that you're doing as well. So a lot of work there, again, to make sure that even in a highly abstracted environment like Java, we can actually map that out very nicely to what's going on in the hardware, which can be very critical to analyzing performance problems that you have out there. So one last thing I wanted to mention that has been hinted at as we've been going throughout the presentation here is that this sort of optimization is not just about the database. It's not just about Java. It's not just about Solaris. The ultimate optimization is, can we make sure that these things are happening at silicon speed? So already, really within the first year that we were part of Oracle, we were able to identify instructions that needed to go into the Spark processor set that would optimize Oracle database, that would optimize middleware technologies as well. So those actually got integrated into the T4 and now the T5 processor. But we have an entire project within the company that's an ongoing thing, and it's actually been mapped out and shared with some of our other hardware partners already, which is the idea of software in silicon. And again, this is what you can do if you have the entire purview in your field of vision. If you have the applications, if you have Java, if you have database all under your same ceiling, there's some incredible things you can do. So we can put database query acceleration on the hardware itself. We can figure out ways to optimize Java graphic contents within the hardware itself. We can make sure that as we're taking code paths and protecting them and making sure that we're checksumming them, that's integrated into the silicon as well. And so as we get later and later generations of Spark, and again, our investment in Spark has just gone up enormously over the last 4 years, we can just do some really incredible things from the chip level, which is then presented through the OS level all the way up the stack. So let me wrap up here and hopefully leave some time for questions as we go through. Why would you be doing your software deployments on Oracle Solaris? Well, first of all, our investments in the cloud, which has really moved from being a buzzword to a way of life out in the industry, we think are second to none. The innovation that we've done with virtualization, we have a track record on that that goes back 10 or 15 years now in delivering this directly into the operating system. Where we're going, where we've arrived with provisioning is just incredible, I think, in terms of being able to develop your applications and deploy them as quickly as possible. Just some amazing things that we're doing out there is, of course, proven track record with security, adding this extra, we think, vital and necessary point of being able to demonstrate compliance. That's important not only for your deployments, but also for being able to get the proper approvals from either your internal or external regulatory agencies. Standards-based management, OpenStack is part of that, Open Daylight is part of that, technologies such as Puppet and Chef built directly into the OS and integrated in with the low-level components, so that that's kind of, the differences between Solaris only appear when you need them to. It does not add additional complication as you're bringing in people into the organization as well. And again, I'll just highlight this because it was just a staggering number. We had a customer in Wall Street who was able to demonstrate they were getting 16 times better efficiency with their system administrators on Solaris compared to the older operating system that they'd been using previously. Again, sort of the price point, we're building in things other people charge for, and we're integrating in a very seamless way. And by the way, that goes back into our service organizations as well, where the service teams all understand the technologies because they all work together on them on a daily basis as well. So we're in a unique position with Solaris and with Oracle that by being the company that brings you Java, Java middleware, and Oracle database, we can bring out that best technology in there as well. Where I'm talking about futures, again, I want to be clear, this is our general product direction. Software is software, so sometimes timelines stretch out a little further than we hoped. I try not to nail down any timelines here, but just understand the normal safe harbor caveats. We fully stand behind what we're doing, but subject to change at times. So that's what I have. Again, I'd like to thank you all for tuning in with us right now. I left a whopping 2 minutes, but I was promised that we can actually go over if there are additional questions at this point.
We do have several questions, so thank you very much, Larry, for that presentation. So I'll go ahead and jump right in. The first question is, can I run Windows Server VMs on Oracle Solaris 11.2 OpenStack?
You can manage them with OpenStack. So if the Windows Server technologies are using the same sort of OpenStack configurations, and one of the things that was announced at the last OpenStack conference is that there are companies that are doing work in configuring those in there. We can manage them. You cannot run Windows on top of Solaris, but you can use the same management technology. And by the way, the flip side of that is that anybody that's connected up to the OpenStack backplane can use their technologies that they're familiar with today to manage the Solaris deployments and instances.
Great. And we do have another OpenStack question. How does OpenStack on Solaris integrate with Oracle Enterprise Manager 12 Cloud Control?
That's still to be determined at this particular point. The Oracle Enterprise Management people, the Oracle Enterprise Manager people have announced their intent to work on OpenStack, but per our safe harbor statement, there are no concrete delivery points that we can give at this particular moment.
Okay, perfect. Next question. We use non-Oracle hardware that is certified for Solaris 11.1. How can I ensure that it will be certified for Solaris 11.2?
We fully expect that to happen. One of the things that we have is a compatibility guarantee out there. So this is, again, something that we pioneered in the industry. Back in the year 2000, we guaranteed that applications that worked on earlier versions of Solaris will continue to work on forward versions. Similarly, the technologies that we're using with Oracle Solaris 11.2 at the hardware interface level are additions to, they're not superseding what happened previously. So our expectation, and check the hardware compatibility list for this, is that anything that you're deploying on top of or deploying with Oracle Solaris 11.1 today should be able to, I hate to use this word again, seamlessly, but there's the word, seamlessly upgrade to 11.2.
Perfect. And this is going to be our last question. Would these optimizations work on Oracle Solaris 11.2 using an x86 box or only with a Sun T5 box or appliance?
Now, this would work on both x86 and SPARC systems. All the technology that we're talking about here is platform agnostic. The operating, we do one operating system development. The only place where we do anything different for operating system engineering, depending on the hardware, is just the hardware driver interfaces themselves. The higher level technologies are all the same. So since that was the last question, I will mention, by the way, I worked very hard on this. The one thing that was missing from this presentation is I did not use the red 7-layer stack anywhere in the deck. So I just thought I'd give you all a break from that on this particular presentation.
Great. Well, thank you so much, Larry. I'd like to give a huge thank you to our speaker today. Before we conclude, please make a note of our upcoming webinars and past webinars by visiting www.ioug.org. A recording from today's webinar will soon be available also on www.ioug.org in our Resource Center. We'd like to thank our speaker and everyone online for attending the event today. There is a survey after this webinar for you to complete. We thank you in advance for your feedback. Thank you all again for attending today's webinar, and have a great day.